In this video, we are going to review the topic of domain. So first of all, let's remind ourselves what domain represents. It represents all the possible x values. Now, if you're given a graphical representation of the function, the easiest way to do your domain is to look at the graph from the left side of the graph to the right side. So on the left side, this graph keeps going and going and going. So all these negative values are represented on the graph. So for example, when x is -1, it has a point on the graph. When x is -2.5, it has a point on the graph, at least one. So as we go to the left, all the negative numbers are being used, and then all the numbers up to 3. So we put a comma and a 3, and because this is solid, it's not an open circle, 3 is included as part of this graph, we use a bracket. Now in the next set of examples, we are given the equation. So if you know what the graph looks like, for example, since this is a polynomial with the highest exponent of 2, when the highest exponent of it is a 2, we know it's going to make a parabola. So if you go from the left to the right, you would see that it goes to -infinity and a positive infinity. So one way to do these ones with equations is to think about what the graph would look like. However, we can also do these just by thinking about what x can be. So for example, over here, x is going to be squared. So think about it. What numbers can be squared? So for example, negative numbers can be squared. -4 squared is 16, -4 is 12. You can also square positive numbers. +4 squared is also 16. You can square 0. 0 squared is 0, and then 0 minus 4 is -4. So any number can go in this x spot right here and be squared and then subtracted by 4. So our domain here is all real numbers. And again, we can see that because if we had the shape memorized, the graph memorized for an x squared, we know it makes a parabola. Okay, so if we take a look at number 3. So in the numerator, there's a 1. Now this is a fraction. So coming into this class, we should know that zeros are totally okay in the numerator, but in the denominator, they are bad news. We don't want zeros in the denominator. So that's why we ignore the numerator. We don't care what the numerator is. It's the denominator that can't be 0. Now when we solve this equation over here, since there's exponents, that's how I know this comes from chapter 6 in this class. So when you're solving an equation with exponents, the way that we've learned how to do it so far until chapter 9 is to solve this by factoring. So this is a difference of squares. So in other words, in my head, I'm thinking x times x is x squared. 2 times 2 is 4. So we can factor it as x plus 2 and x minus 2. And then we set each factor and solve. And then we get one bad number, x cannot be -2. And the other bad number for this problem is 2. Okay, now it says to write our answer in interval notation. So this is totally optional. This is just for those who are visual. This is what we're saying. We're saying that x cannot, and it's an open circle. That means it can't. It's not included. So -2 and 2 are the only numbers that, if you put it right here for x, will make 0 in the denominator. So for example, 2 squared is 4. 4 minus 4 is 0. So we can't have 0 in the denominator. But all these other numbers are totally cool. They won't make 0 in the denominator. So we go left to right. So any negative number up to -2, but not including -2, or any number here in between -2 and 2, or any number bigger than 2 can go into this equation and not cause undefined. Okay, so now if we take a look at example 4. So the denominator of a fraction cannot be 0. So if we look here, there's just a 3. 3 is 3. There's no variable. When there's a variable can change, right? You can change the number. But since this is a 3, it's never going to be 0. So that's why the domain for this one is all real numbers. So we always ignore the numerator because, again, the numerator of a fraction, totally cool, is 0. It's the bottom that can't be 0, and it never will because it's just a 3. So that means any number can go in this X spot up here because the top of a fraction can be 0, negative, positive. Okay, so if we look at this one over here, so domain is what can you plug in for X? What are all the possible X values? Well, this X right here is being squared, and any kind of number can be squared. A positive number can be squared, 0 can be squared, negatives can be squared, fractions can be squared, so any number. However, this X can't be any number because it's inside this radical and the index is even. The inside of the radical, so just the X minus 3 is inside, has to be greater, or it could equal, so think about what's the smallest number that isn't negative, and that is 0. So this number in here has to be a big number, or you could have 0 in the radical. The square root of 0 is 0. So then we're going to solve this, and remember when you solve inequalities, you solve just like an equation, but if you divide by a negative, this symbol switches. I'm not dividing by a negative, so I don't need to switch the symbol. So this is our domain here. Any number that is greater than or equal to 3 can go into the X spots here. So even though this can be any number, this has a restriction. So this is optional. But if I graph this, any number greater than or equal to 3, it would look like this. And then if I go left to right, this can help people write it in interval notation. But again, the graph is totally optional. Okay, so now if we look at example 6. So in this problem, we have a radical. But if we look at the index here, it's odd. So when the index is odd, we know that we could have a positive number inside. So this is saying what times itself 3 times is 8. So this has an answer of 2. We could also have negative numbers inside when this is cubed, because this is saying what times itself 3 times is -8. And -2 times -2 times -2 gets us -8. So the answer to this is -2. We could have 0 inside, because what times itself 3 times is 0. So positives would work, negatives would work. So this X right here can be any number, because if it makes it positive, we're cool. If it's negative, we're cool. If it's 0, if it's a fraction, any number can go into the radical. So when it's odd, our domain is all real numbers. So if this was a 5 instead, or a 7 as the index, the answer is still all real numbers. Okay, so this one we have a radical again, and the index is even. So when it's even, we know that we can't have negatives inside. So in other words, we want the -2x plus 4 to be a big number, a positive, or it could equal 0. So now we're going to solve this inequality. So subtract 4 to both sides. And then here we're dividing by a negative. So when we divide by a negative, remember that is when we switch the sign. So this step right here that we're doing to both sides is why we're switching the symbol. Okay, so now to write our domain and interval notation, I'm going to go ahead and graph it real quick just to make it visual. This is saying all the numbers that are less or equal to. And then if we go left to right, any negative number and any number up to 2, including 2, can go in for this x, and the inequality wouldn't be negative.